evaluate a triple integral. We have dy, dz, dx. X corresponds to the outer integral, x from 1 to 4. Z corresponds to the middle integral, z from 1 to e squared. Y corresponds to the inner integral, y goes from 0 to 1 over xz. The integrand is ln(z). So the first step that we are doing is we are integrating ln(z) with respect to y. Y is a variable. There is no y in here, and then we are treating ln(z) as a constant. So the first line from 1 to 4, from 1 to e squared, and then ln(z) is just a constant. So we leave the constant alone, and then what is the integral of a constant? Let's say the integral of 1 dx. What is that equal to? Or the integral of 1 dy. Integral of 1 dy. What is that equal to? That is equals to just y, right? Because you take the derivative of y, you get a 1. Okay? So this will be just a z, such that z goes from 0 to 1 over xz. And then you have your dz dx. Plug in. I like the 0 because at that you just makes the whole thing 0. So you have 1 over 4. 1 over e squared, and then plug in, you have a 1 over xz, right? And then you have a ln(z) times 1 over xz, and then followed by the differential dz dx. What is the next step? How about we try a u substitution? How's that? We try a u substitution. So I am going to let u equals to ln(z), and then du equals to 1 over z dz, and then multiply the z to the other side, z du is equals to dz. And then I will do a change of variable, and then move that to this dz. Okay, how about the 1 and the e squared? That is in terms of what? That is in z, right? So that is in z as well. So we are going to do u when z is equals to e squared. What is this? ln e squared, you can bring the 2 to the front, and then ln e is equals to 1. U, when z is equals to 1, you have a ln 1 that is equals to 0. And then the next step, you do the integral, so from 1 to 4, and then now watch me. And then this will be integral, u from 0 to 2. Everything is in terms of u. And then you have a ln(z), no change with that. Oh, ln(z) is, by the way, is equals to u. There is a change. And then the 1 over xz, no change. Okay, so the 1 over xz, no change. And then the dz is z du. And then you have your dx. You see how clear that is? And then the z is gone. And then how about the x? I can ignore the x because we are doing a du. X is just a constant. You know what? The next step, I can even do this. I can even do an integral from 1 to 4. I pull the x here. And then I'm integrating the u only. So that will be a 1/2 u squared. U goes from 0 to 2. And then you have a dx at the end. And then u squared minus 0, that will be 4 minus 0 equals to 4. 4 divided by 2 is equals to 2. And then the very last integral, 1 to 4, x. So this is a x dx, right? And then you have a 2 just like right here. Okay, that should be very easy. Oh, x. No, not x. Not x. Not x. 1 over x. 1 over x. Okay. 1 over x, that changes everything. The integral of 1 over x, that is not a power rule, right? The integral of 1 over x is ln. So that is 2 ln absolute value of x from 1 to 4. And then 2 ln 4, you can remove the absolute value because 4 and 1 are positive. 2 ln 1, ln 1 is 0, so the answer is 2 times ln 4. That's it. Oh, for this triple integral, I suggest you to just Google triple integral calculator. Just go to Google, just look this up, triple integral calculator. Input this integral to that calculator. Make sure this answer is right because there are so many steps. Sometimes you have to use the unit circle to evaluate sine, cosine, and tangent. Sometimes you have to do a bunch of common denominators, reducing fraction. You don't want to make a mistake in those little steps, right? So I suggest you to use those triple integral calculator to check your work. Okay, so that is the end of this video. If you like the way I explain triple integral, thumbs up, like this video, subscribe to my channel for more contents like that. And as always, I will meet you all in the next video for more integral like that. Signing out.